We are working on applying the derivative, and let's go ahead and start a new example. This example is going to focus on everybody's most favorite type of applied math, which is over money. So the specific money that we're going to be talking about here is profit. We want to figure out how can we earn the most money that we possibly can. So profit is, of course, listed as the amount of money earned. Well, to figure out our profit, then we have to base it off of revenue and cost. So revenue is the amount of money that you're taking in, and cost is the amount of money that you're spending, the amount of money that you're putting out. So if that's the case, then profit is the amount of money brought in minus the amount of money that you've spent, or revenue minus cost. So the way that we see this in a lot of applications is listed by this formula right here, where the P of X stands for the profit, the R of X stands for the revenue, and the C of X stands for the cost. Profit equals your revenue minus your cost. Now that's pretty easy to understand, but we might have to adapt it depending on how the problem asks the specific question. So one way it asks is we don't just want profit in general, we want profit per item per se. So if they give us a set number of items, how do we calculate the profit depending on the number of items that we are selling, producing, or whatever the situation may be? So I've over-explained it in this slide here. Basically, we just take each step and we multiply it by the number of items. So if we want revenue for a specific number of items, we take the number of items times our revenue. If we want cost for a specific number of items, we take the number of items times our cost. So in the same sort of format, if we want the profit for the specific number of items, we take those number of items times our profit equation, which is revenue minus cost. Okay, so let's use this knowledge then, and let's go ahead and look at our first example. This is a consumer expenditure example. So the example is the demand for a particular commodity is given by the D of X equation, where it's equal to negative 35X plus 200, and that is X is the number of units that will be sold or demanded at a price where the price is dependent upon your D of X equation, and that's the number of dollars per unit. So we want to do three different things with this here. The first one is we need to set up our function. So what is the expenditure equation? So express the consumer expenditure E as a function of X. Once we get that set up, then we can start applying our calculus. In part B, we want to find the average rate of change from 4 to 5. In part C, we want to figure out what's the instantaneous rate of change when X is specifically equal to 4. And if we can figure that out, we want to know, is it increasing or decreasing at that time? So let's start with part A. Find the consumer expenditure as the total amount of money consumers want to pay to buy X units. And so basically the second part here, express the consumer expenditure E as a function of X. Basically it's asking you to find this equation here. So the expenditure report as a function of X. That's what it's trying to say there. So we're not going to use our full profit equation here. We don't have both revenue and cost. We basically just have the number of units sold and the price that they're selling at. If we want to figure out our expenditure then, we have to adapt that compared to the number of units that we are specifically selling. So if we want to figure out the demand here, we take the number of units that we are selling, so that's the first thing, the number of units, and we multiply it by the price per unit. So that way we figure out what our total demand or our total expenditure here. Well, the number of units is defined by X, and the price per unit is defined by our D of X equation. But more importantly, we know that we can substitute in what our D of X equation is. And so that is negative 35X plus 200. So to simplify this, all we have to do then is distribute this x here. So our expenditure equation as a function of x is negative 35x squared plus 200x. So we have just finished part A. We have set up our expenditure equation. Again, it's the price per unit times the number of units that we are selling. Okay, now we're going to take this and we're going to apply this. So we're going to look at part B, trying to find the average rate of change, where our expenditure equation we just found was negative 35x squared plus 200x. So basically, to find the average rate of change, we use the slope formula. Our slope formula is y2 minus y1 over x2 minus x1. Now we know our two x values, 5 and 4, so how do we come up with our two y values? Well, you just take your x values and you just substitute them in for the equation that you're focusing on. So I take my e of 5, that's my second y value, and I subtract my e of 4, that's my first y value. Once you do that, that will give you the average rate of change. Now, I'm not going to walk you step by step through this problem here because I feel like I've already done plenty of examples of this in the last couple of videos and sections. So I'm just going to work out the details and you can check your answer from there. So this would be a great time to pause the video and see what answer you get on your own. Okay, so when I did the math here, I got the answer of negative 115. Remember, this is a rate, so our label is something per something. In this specific problem, it is dollars per unit, so if I wrote it out, it would look like this here. Or the way that it makes more sense is negative $115 per unit. All right, part C says then use calculus to find an instantaneous rate of change of expenditure with respect to x when x is equal to 4. Is it increasing or decreasing? Well, if we want the instantaneous rate of change, we know that we should be using the derivative. So our derivative formula is typically f of x plus h. Well, we're not going to use f, that's not our function. We're going to use e of x plus h minus e of x all over h, and that is the limit as h goes to 0. And our notation then is e prime of x. Now, again, I'm not going to walk you through this step by step because I feel like I've already given you plenty of examples for that. But I will show the answer, so I suggest that you pause the video and see what you get for this problem on your own. So I have done all the work here to find the derivative. I've done the difference quotient, and then I plugged in the limit using my proper notation. So you figure out that the derivative, or e prime of x, is equal to negative 70x plus 200. Now we're going to go back and use this in our actual application here. So we have e prime of x is equal to negative 70x plus 200. If we want the instantaneous rate of change when x equals 4, all we need to do then is substitute 4 into our equation. So negative 70 times 4 plus 200. We come up with the answer to be negative 80. Remember, this is a rate. So our rate is dollars per unit. Or our final answer here then is negative $80 per unit. So if we wanted to know if our rate was increasing or decreasing at this time, we look at the sign. Since our sign is negative, that tells us that our rate is decreasing at this time. So we have just finished up our first example applying money into applications of using the derivative.